Hello, right, here we go. A little geometry lesson. First of all, we're going to do, parallel lines, and then we're going to do polygons. Right, parallel lines. This is finding out, first of all, a parallel line is this. Yeah, it's a line, and you have a little arrow on there to show that they're both parallel to each other. So, like railway tracks, they never get further apart and they never get closer together. And with this, we can find, knowing that they're parallel lines, we can find out angles between them. So normally we have this, a parallel line, and there's another parallel line. And we have a line that goes at an angle, a bisector, or no, it's not cutting it in half. But anyway, we have lines, and because these are parallel, there's something that happens with all the sides of the angles. So if we have that angle there, and say that is, I don't know, 40 degrees, yeah? This angle there is also 40 degrees. And they are called corresponding angles. So you've got corresponding angles, and there are more corresponding angles as well in here. So let's have a look. So this one is corresponding to this one. This one, I'll colour that in so that we know that it's a different one, is corresponding to that one. So they will be exactly the same size as each other. And the last ones are this one here is corresponding to this one here. So it just means it's in the same place as the other one. So when we've got corresponding angles, we can work out what all the other ones are. Now, there's an extra bit of knowledge that we hear this. Oh, that's not parallel to anyone. So if we have an angle there, and we'll say that that is 40, we've got angles on a straight line. And the angles on a straight line add to 180. So if this is 40, this one here will be 180 minus 40, which equals 140. So that angle there is 140 degrees. So if we go back to this one, that one's 40, this one's 140. So this corresponding angle down here is also 140. Now, more straight lines is to find the green one. So if we have that, and we have that, and there's our 140 there, yeah. This one here is again on a straight line, so we do 180 minus 140, and then that equals 40 again. So this becomes 40, and its corresponding angle also becomes 40. And this black one here will be 180 minus 40, so this will be 140, and the corresponding angle is 140. So if you're given one angle, you can find yourself all the way around. You can find every one. Now, see, these opposite ones are the same. Yeah? 140, 140, 40, 40. And that is this. Yeah? So that's 40, that's 40. And that is called vertically opposite. Now, sometimes in these geometry problems, not only does it ask you to find the missing angle, but it also may ask you why. So this one is 40, this one is 40 because they are vertically opposite. This one is 40 and this one is 40 because they are corresponding angles. And this one is 40 and this one is 140 because it's angles on a straight line. Now, getting a bit full up there, so let's go down and do some more. Right. Right, so another one is this, that one, and that one. And these are called alternate angles. And they're the same as each other, alternate angles. Now, we'll call this one 40 again. Now we know that this one is 40 because it's an alternate angle. But if we did the go round the long way, we could say that one is 40 because it's vertically opposite, and that one is 40 because it's corresponding to that one. So yeah, you can go that way or you can go straight down as alternate. Now the straight line said that this one was 140, and look at these two angles here, they add to 180. This one and this one. And 140 plus 40 equals 180. And they are called allied angles. So you can use allied, alternate, corresponding, vertically opposite, angles on a straight line, anything to find your way around these shapes. And the recommendation that I'll make here is if you've got a complicated shape in a exam question, do not worry that you can't find the angle you're after immediately. Just find what you can and see where it leads you. Now, what's the other thing here? So that is 40 on a straight line or alternate. That's 40 on vertically opposite, and that's 40 vertically opposite as well. Now these 140, 140, 40 and 40 all added together, 4 fours are 16 and 111 is 360. So we've got this, that the angles around a central point add to 360 because they go round in a circle. So that's a little bit on parallel lines. Now the other bit, part of this mini lesson, is internal, external angles. Now this is the polygon. What a polygon is, it's a many-sided shape. And you get regular shapes and irregular. And a regular shape is all lovely, everything is supposed to be exactly the same size. Yeah, that's my best regular shape. Irregular shape is this, where all the angles are different and all the sides are different lengths. But a regular shape, everything is the same. And what we're going to do is find internal angles, the sum of internal angles and external angles, anything to do with a regular shape. So a regular triangle, which is an equilateral triangle, the three angles in it add to 180. So each angle will be 60 in an equilateral triangle. So that's something to know. Now if you have a rectangle or a square, then you've got 4 right angles which are all 90 degrees. So 4 nines are 36. So this adds to 360, the internal angles. Now when we move on to polygons, we sometimes, I've got to imagine that this is a regular shape, yeah. So this is a regular polygon. Polygon. And it's, what's it? It's a pentagon, isn't it? 5-sided shapes. So we will want to find the sum of all the angles. How much do all the inside angles add up to? Now, there's several ways of doing this. Let's just get rid of that little bit first. Can't, yeah, there. Right, Right, so what we do, first way, is we extend this 1, 2, 3, 4, 5. So we get 5 external angles. Now, we've had to go around 360 degrees to get those 5 angles all the way around. So if we want to find out one of these, there, got that one, it will be 360 divided by 5, yeah, which is 72. So there's 72 degrees for the external angle. Now, the next bit to find is the internal angle. Now this is on a straight line. So the internal angle will be 180 minus 72, which is 108. 108 for the internal angle. 108. Now internal angles, you've got 1, 2, 3, 4, 5. So the sum of the internal angles is 5 times 108, which equals 540. So that's how to find the sum. It doesn't matter how many sides. If we had a 6-sided shape, now this is all regular, 6-sided shape, which is a hexagon, we just find the external angle there, which is 360, and this time divided by 6, because there are 6 sides. And so that will equal 60 degrees. So there's 60. The internal angle will be 180 minus 60, which equals 120. And the sum of the internal angles is going to be 6 times 120, which is 720, I think. 6, 12, 72, yeah, 720. So we can find the sum of the internal angles by doing it this way. A second method. 1, 2, 3. Oh, that's rubbish. That's not very good, is it? I wonder if you've got a proper... No, there isn't there. Isn't a 5-sided shape. So 1, 2, 3, 4, 5. Yeah, there's our regular pentagon. Now the other way of doing this is finding the sum of the internal angles is if you start from any corner and draw a line to another corner and then to another corner, you've made 3 triangles. So the sum of the triangles is 180, 180, 180. So you've got 3 times 180. 3 18s are 54, so you get 540. So you can find the sum of the internal angles that way. Now this is great because this is the way, if you had 1, 2, 3, 4, 5, an irregular, you can't find the sum of the internal angles of an irregular shape by going the external, then the internal, and multiplying it by 5 because every angle is different. But if you do this, 1, 2, you got 180, 180, and 180, yeah? And that again equals 540. So that's how to find the sum of the internal angles, whether it be a regular or irregular shape. And for regular shapes, you can find the external and the internal. So that's that one.